Hello and welcome to the next section of our course. In the previous section we learned how to manipulate vector data. This section will be dedicated to manipulating raster data. In this section we would learn the various techniques to work on raster data, and then we would modify the data for analysis, and then we would learn how to calculate new rasters. Welcome to the first video of this section. In this video we're going to talk about the raster format in more details compared to what you learned in previous sections. Then we'll perform some basic statistics on the elevation data we downloaded from USGS. Finally, we'll learn how to reproject raster data. Open Activity 3.1 in RStudio and run the first 17 lines of code to load the necessary packages and the DTM data we downloaded in previous sections. The object we just imported is a raster layer, and as you can see here, R provides us with a lot of information about it. We have the dimensions in number of rows, columns and cells. This is because a raster is basically a large rectangular matrix where each cell has a value corresponding, in this case, to elevation. Then we have info about the resolution of the raster, its projection, the file source, the name of the raster and its minimum and maximum values. All these data can be accessed individually with specific functions. For example, we can check the number of rows in the raster with the function nRows, which is the same used for matrices. Similarly, we can check the number of columns with the function ncol and the number of cells with the function ncell. The function res provides a simple way to access the information regarding the resolution of the raster object. This raster is unprojected, thus these numbers are in degrees. The resolution is around 0.01 degrees, meaning approximately 1 square kilometre. The package raster is fully integrated into R and provides us with a series of functions we can readily use with our raster objects. One of these functions is cellstats with a capital S. This allows us to calculate whatever statistical index on our data. In this case, I'm calculating the mean elevation value. The same result can be achieved by extracting only the cell values from the raster object and then calculating their mean. To extract the raster values, we can simply use 2 square brackets after the name of the raster. This extracts the values in a numerical vector. Once we have this vector, we can calculate the mean and other statistics as we did in the section named Descriptive Statistics. We have to remember though to always add the option na.rm equals capital T. This is because a raster object is always a rectangular matrix, even though our actual raster has a different shape. For example, in my case the DTM has this strange shape. However, the raster is rectangular, therefore we'll have data also in this white area. To demonstrate this, we can assign a value to all the NAs present in the raster and then plot it again. As you can see, now the white area has a colour corresponding to 2000 on the colour scale. It's important to remember this aspect of raster objects when we work with them. Luckily, the raster package is integrated in R, and therefore a lot of functions work with raster objects by default, without the need to extract values from rasters. For example, the function hist works perfectly with raster objects, and here we do not need to worry about NA because they will all be handled internally. The last thing we're going to learn in this video is how to reproject raster data. This is very simple to do because there is a dedicated function similar to what we used for vector data. The function is projectRaster with a capital R. This function takes 2 arguments. The first is the raster object, while the second is the option CRS, that is the reference system we want to use. In this case I'm using the World Mercator projection. Additionally, we can use the option filename and specify where to save the new projected raster created by this function. Please be aware that reprojecting a raster takes some time. To check our results, we can once again use the function projection to print the projections of the original and reprojected raster. We can also check the resolution of the new raster. As you can see, it's not precisely a 1 kilometre resolution, but it's very close to it. Good job, guys! In this video you learned how to handle, understand and start to work with raster data in R.